This content is provided for educational and entertainment purposes only and does not constitute professional career, financial, or legal advice. Automotive repair involves significant physical risks, including but not limited to high-voltage electrical shocks from electric vehicle systems, chemical exposure, and mechanical hazards. The automotive industry is subject to rapid technological shifts and varying regional regulations. You should conduct your own thorough due diligence, consult with certified vocational counselors, and research specific state licensing requirements before committing to any educational program or financial investment. The historical trends and case studies discussed do not ensure specific future results. In the next 10 minutes, the car sitting in your driveway will become more computationally complex than the most powerful supercomputer from 20 years ago. As of March 2026, the average cost of a simple out-of-warranty repair at a United States dealership has surged past the $800 mark, while specialized labor rates in major metropolitan areas like New York, San Francisco, and Austin have officially eclipsed $250 per hour. We are currently witnessing what industry analysts call the Great Diagnostic Divide. On one side, you have millions of vehicle owners who are being priced out of mobility because they cannot afford the spiraling costs of maintenance. On the other side, there is a massive gaping hole in the American workforce, where over 100,000 technician roles remain unfilled despite starting salaries for master-level mechatronics specialists frequently hitting the six-figure range. If you have ever opened your hood, looked at the sea of plastic covers, sensors, and high-voltage orange cabling, and felt a sense of total helplessness, you are not alone. The era of the shade tree mechanic, the person who could fix anything with a basic set of sockets and a bit of intuition, is effectively over. In its place is a high-stakes, high-tech landscape where a single mis-calibrated LiDAR sensor or a corrupted firmware update can brick a $40,000 asset. This raises a critical, high-stakes question for every American in 2026. Is an auto repair class actually a pathway to financial sovereignty and a recession-proof career? Or is it a legacy education model that is failing to keep up with the brutal pace of automotive evolution? We are going to dive deep into the raw data to solve this problem for you today. This is not a surface-level overview. It is a masterclass in the ROI of automotive education in a world dominated by software-defined vehicles. We will examine why the traditional internal combustion engine curriculum is being dismantled in favor of high-voltage systems, why the right to repair movement is the most important legal battle of your lifetime, and whether the potential outcomes of a 2-year vocational degree can actually outpace a 4-year liberal arts education in the current economy. If you are a hobbyist looking to save money, a career changer looking for stability, or a parent wondering if trade school is a viable path for your child, you need to understand the hidden architecture of the 2026 auto industry before you spend a single dollar on tuition. To understand why an auto repair class is such a contentious topic right now, we have to look at the specific historical trends that led us to this bottleneck. For decades, automotive repair was viewed through a purely mechanical lens. You learned how to rebuild a carburetor, how to lap valves, and how to change a clutch. However, as we sit here in 2026, the modern vehicle is essentially a data center on wheels. A mid-tier electric SUV now contains upwards of 100 million lines of code. For context, that is more code than is required to run a Boeing 787 Dreamliner. When you enroll in an auto repair class today, you are no longer just learning how to turn a wrench. You are entering a field of mechatronics, which is the synergistic integration of mechanical engineering, electronics, and intelligent computer control. Consider the case study of the modern braking system. In 2016, if your brakes felt spongy, you likely had air in the lines or a leaking master cylinder. A basic understanding of hydraulic pressure was all you needed. In 2026, many vehicles utilize brake-by-wire systems. There is no physical connection between your foot and the calipers. Instead, a sensor sends a signal to an electronic control unit, which then commands an actuator to apply pressure. If that system fails, a traditional mechanic might look for a leak that doesn't exist, while a trained technician will use an oscilloscope to trace a pulse-width modulated signal. This shift represents the first major hurdle. The barrier to entry has never been higher, but the reward for those who clear it has never been more significant. One of the primary reasons people consider these classes is the skyrocketing cost of ownership. According to recent 2025 to 2026 consumer reports, the annual cost to maintain and repair a vehicle has risen by 15% year over year, significantly outstripping general inflation. This is driven by 3 factors: the complexity of parts, the scarcity of skilled labor, and the proprietary nature of diagnostic software. Dealerships have historically held a monopoly on the brains of the car. When you take a modern car to an independent shop, they often have to tell you, "I'm sorry, I can't reset that module. You have to go to the dealer." An auto repair class in 2026 is often sold as a way to take back control. But we have to be realistic about what a classroom environment can actually provide versus the reality of the workshop floor. If you are looking at this from a career perspective, the potential outcomes are fascinating. We are seeing a historical trend where the blue-collar stigma of automotive work is being replaced by a new-collar reality. In 2026, a top-tier technician spends more time on a laptop than under a car. They are diagnosing combust network failures and thermal management loops for solid-state battery packs. Because of this, the wage gap between an entry-level technician and a master technician has widened. Case studies from technical colleges in the Midwest show that graduates with specialized certifications in EV powertrain management and advanced driver assistance systems, ADAS, are receiving multiple job offers before they even complete their final exams. However, we must also address the tuition trap. Not all auto repair classes are created equal. In 2026, there is a proliferation of fast-track programs that promise to make you a technician in 6 months. We need to look at the step-by-step reality of what these programs cover. A high-quality 1,000-hour program should ideally dedicate at least 40% of its curriculum to electrical architecture. If a school is still spending 3 weeks on how to rebuild a 4-speed automatic transmission from the 1990s, they are preparing you for a world that no longer exists. The value of the class is directly proportional to its investment in modern diagnostic hardware. For example, a single high-end diagnostic scanner that can bidirectionally communicate with 2026 model year vehicles can cost upwards of $10,000, with annual software subscriptions costing thousands more. If your local community college doesn't have this equipment, the class might not be worth the time regardless of the price. Furthermore, we need to talk about the DIY aspect for the average consumer. Is it worth taking a night class just to fix your own car? In 2026, the answer is a nuanced maybe. While you might learn how to change your oil or rotate your tires, many modern manufacturers are moving towards sealed systems. Some 2026 luxury EVs don't even have a traditional hood that the owner is intended to open. Therefore, the worth of an auto repair class for a hobbyist in 2026 isn't about doing the heavy lifting yourself. It's about diagnostic literacy. It's about being able to read a scan tool, understand the freeze frame data, and know when a service advisor is trying to sell you a $2,000 sensor suite alignment that actually takes 5 minutes of software calibration. In this context, the class pays for itself not through labor saved, but through predatory service avoidance. By the end of this deep dive, you will have a comprehensive framework to evaluate any automotive program. We will break down the specific certifications that actually matter in 2026, such as the L3 Light-Duty Hybrid/Electric Vehicle Specialist credential, and we will look at the actual equipment list you should demand to see before signing a tuition check. The goal is to move you from a state of mechanical uncertainty to a position of technical authority. Whether you want to build a career in the high-voltage future, or simply want to ensure you aren't being taken advantage of at the repair counter, understanding the current state of automotive education is the most valuable tool in your garage. To understand the true weight of an auto repair class in 2026, we have to pull back the curtain on what actually happens when you pop the hood of a modern vehicle. Historically, the internal combustion engine was a symphony of mechanical timing. If a car didn't start, you checked for spark, fuel, and compression. But in 2026, the historical trends have shifted so violently that those 3 pillars are now buried under layers of encrypted software and high-voltage architecture. Imagine if you are standing in your driveway in suburban Ohio, looking at your 2024 hybrid crossover. It won't move. In 1996, you would have reached for a socket set. In 2026, if you reach for a metal wrench without understanding the isolation procedure for a 400-volt lithium-ion battery pack, you aren't just risking a mechanical error. You are risking a lethal electrical discharge. This is why the curriculum of a 2026 auto repair class has been completely overhauled. Consider the case study of Marcus, a 35-year-old former IT professional in Atlanta who decided to take a mid-career pivot into automotive mechatronics. Marcus represents a growing segment of the United States population who realized that the physical world was becoming as digital as the cloud. When Marcus entered his first lab session, he wasn't handed a greasy rag. He was handed a Cat 3 rated digital multimeter and a set of insulated gloves rated for 1,000 volts. The first 3 weeks of his masterclass weren't about engines at all. They were about the physics of electricity and the architecture of the controller area network, or CAN bus. In a 2026 vehicle, every component, from the window motor to the fuel injector, is a node on a high-speed data network. If the window won't roll down, it might not be a broken motor. It could be a packet loss issue on the LIN bus. Marcus learned that without a formal class, he would have spent $500 replacing a perfectly good motor, only to find the problem persisted. This is the first level of ROI. The prevention of the parts cannon approach, where untrained individuals blast money at a problem hoping something sticks. Step by step, a 2026 auto repair class teaches you the high-stakes protocol of de-energizing a vehicle. This is a process that simply did not exist for the general public 10 years ago. You start by identifying the high-voltage service disconnect, often located in the trunk or under a rear seat. But you don't just pull it. You have to wait for the capacitors in the inverter to discharge, a process that can take anywhere from 5 to 10 minutes. A certified class teaches you how to use a specialized scan tool to monitor the live data stream, ensuring the voltage has actually dropped to a safe level before you ever touch a mounting bolt. Imagine if you skip this step. You could accidentally bridge a connection that welds your tool to the frame of the car in a microsecond. The class provides the safety framework that YouTube tutorials often gloss over or ignore entirely for the sake of brevity. Furthermore, we need to look at the transition from 12-volt to 48-volt systems that has become standard in many 2026 American trucks and SUVs. This shift was driven by the massive power demands of modern active suspension systems and advanced driver assistance suites. A 48-volt system can carry 4 times the power of a traditional system, but it also introduces the risk of sustained arcing. If a wire rubs through its insulation in a 12-volt car, it usually just blows a fuse. In a 48-volt 2026 model, that same rub-through can create a localized plasma torch that can ignite a fire before a fuse even reacts. Case studies from insurance adjusters in 2025 showed a 22% increase in total loss fires caused by improper DIY electrical repairs on high-voltage systems. An auto repair class in 2026 is, in many ways, an insurance policy against the total loss of your second most valuable asset. Now let's look at the software-defined vehicle, or SDV. Imagine if your car's transmission started shifting roughly. In the past, this meant a mechanical failure or a fluid leak. In 2026, it is more likely a conflict between the transmission control module and a recent over-the-air update for the adaptive cruise control. A modern auto repair class spends significant time on flash programming. This is the process of rewriting the software on individual control modules. Without this knowledge, you are tethered to the dealership. The potential outcomes for a student who masters flash programming are immense. They become the digital locksmiths of their community. In 2026, the ability to reflash a corrupted proximity module is the difference between a car that stays in a garage for 3 weeks waiting for a dealer appointment and a car that is back on the road in 30 minutes. We also have to discuss the physical tools. The barrier to entry for automotive repair has moved from brawn to precision. In a 2026 classroom, you will see students using thermal imaging cameras to find parasitic draws on a battery. If a car sits overnight and the battery dies, a traditional mechanic might spend hours pulling fuses one by one. A 2026 student is taught to look through an infrared lens to see which module is glowing with heat, indicating it hasn't gone to sleep properly. This level of diagnostic efficiency is what separates a hobbyist from a professional, and it is almost impossible to learn through trial and error without the expensive equipment provided in a vocational lab setting. Let's dive into the data regarding the tool gap. To properly service a 2026 vehicle, the required tool investment has tripled. A standard set of wrenches is now just 10% of the kit. The other 90% consists of specialized oscilloscopes, pressure transducers, and ADAS calibration targets. An auto repair class gives you access to these 5-figure tools for the price of tuition. For someone like Sarah, a college student in Arizona who wanted to maintain her own vehicle to save money, the class was a gateway to tools she could never afford on her own. She used the school's $15,000 ADAS calibration rack to realign her windshield camera after a rock chip replacement. If she had gone to a specialized shop, that calibration alone would have cost her $700. By the end of her first semester, the savings from that single task had already covered half of her credit hours. The historical trends also show a massive shift in the right to repair legislation across the United States. In 2026, more data is being unlocked for independent students than ever before, but you need the formal training to know how to access the secure gateways. Most 2026 models use a secure gateway module that blocks unauthorized scan tools from making changes to the car's settings. A formal class provides you with the credentials and the NASTF, National Automotive Service Task Force, registration required to legally bypass these gateways. Without this, you are essentially locked out of your own car's brain. But what if the class isn't about saving money? What if it's about the potential outcomes of a career in a world where general mechanics are disappearing? We are seeing a new class of automotive surgeons emerging. These are people who don't just fix cars. They perform forensic data analysis on vehicle accidents and specialized retrofits for autonomous delivery fleets. The 2026 auto repair class is the foundational layer for this high-income bracket. If you think you are just learning to change oil, you are missing the forest for the trees. You are learning the language of the modern world. As we look toward the next phase of this masterclass, we have to address the gray market. With the cost of repairs so high, a secret economy has emerged around salvaged high-voltage components and jailbroken vehicle software. Is it possible to use your classroom knowledge to navigate this world? Or is it a legal minefield that could lead to your vehicle being blacklisted from the manufacturer's network? In the next part, we are going to look at the specific 2026 legal landscape of vehicle software ownership and why the class you take today might determine if you actually own your car tomorrow. To understand the legal landscape of 2026, you first have to realize that you no longer just buy a car, you license its functionality. This is the era of the software-defined vehicle, and the legal battleground has moved from the physical driveway to the digital cloud. Historically, if you bought a car, every bolt and gear belonged to you. In 2026, the physical chassis is yours, but the code that tells the fuel injectors when to fire or the lane keep assist when to intervene is often considered the intellectual property of the manufacturer. This creates a massive hurdle for the average American. Imagine a character named Jim in Columbus, Ohio. Jim buys a pre-owned 2024 electric sedan. One morning, his heated seats stop working. Not because the heating element is burnt out, but because the software subscription from the previous owner expired, and the car's secure gateway module has locked the hardware. If Jim had no formal training, he might spend hundreds of dollars at a shop just for a technician to tell him he needs to pay a monthly fee to an app. But in a 2026 auto repair class, Jim would learn about the Digital Millennium Copyright Act and how it intersects with the right to repair. Students are taught step-by-step how to use J2534 pass-through devices. This is a critical piece of hardware that acts as a bridge between a laptop and the car's onboard diagnostics port. In a classroom setting, Jim would learn how to legally navigate the manufacturer's service portal. He would see that instead of a mechanical fix, the solution involves a handshake protocol between his laptop and the OEM cloud servers. This is not about hacking. It is about the authorized service procedures that are now a mandatory part of any legitimate automotive curriculum. Historical trends show that manufacturers have tried to keep these software keys behind a paywall, accessible only to franchise dealerships. However, the 2026 legal environment in the United States has seen a surge in state-level right to repair expansions. Students in a modern auto repair class are given a front-row seat to this evolution. They learn about the National Automotive Service Task Force, or NASTF. This is an organization that verifies the identity and criminal background of a technician before granting them the digital keys to reprogram security-related modules, like immobilizers or electronic steering locks. A case study from a vocational program in Massachusetts recently highlighted a student who saved a local small business over $5,000 by successfully navigating the secure gateway of a 2025 delivery van that had been bricked by a botched over-the-air update. The student didn't use a hammer. They used a verified digital credential they obtained through their course of study. This brings us to the high-stakes world of the gray market. Because the cost of official software subscriptions can be astronomical, sometimes exceeding $300 for a single day of access to a manufacturer's database. A shadow economy of jailbroken diagnostic tools has emerged. You might see ads online promising a tool that can bypass all security for a one-time fee. In an auto repair class, instructors break down the potential outcomes of using such devices. Case studies show that using unverified, cracked software can lead to a permanent diagnostic trouble code that is uploaded to the manufacturer's central server the moment the car connects to a Wi-Fi network for a map update. Once flagged, that vehicle can be blacklisted from receiving critical safety patches, or even have its fast-charging capabilities disabled for liability reasons. The class teaches you that in 2026, The risk of digital contamination is just as real as the risk of putting the wrong fluid in a transmission. Let's look at the data regarding the cost of these digital barriers. In 2020, an independent shop could survive with a few high-end universal scan tools. By 2026, data suggests that 70% of repairs on vehicles less than 3 years old require some form of manufacturer-specific software intervention. A deep dive auto repair class teaches you how to perform a cost-benefit analysis on these subscriptions. For a DIY enthusiast, paying $50 for a 72-hour access window to the official factory service manual and programming suite is a massive win compared to a $400 dealership diagnostic fee. But you have to know how to use that 72-hour window efficiently. The class provides the step-by-step workflow. You perform your physical repairs first, you verify your wiring with a multimeter, and only then do you clock in to the expensive software to perform the final module calibration. Imagine if you tried to replace a simple radar sensor in your front bumper after a minor fender bender. In 2026, that sensor is tied to the vehicle's VIN. If you just plug in a new one, the car will generate a component protection fault. The cruise control will be disabled, and the emergency braking system will go offline. In a 2026 masterclass, you would learn the adaptation process. This involves placing the car on a level surface, using a laser leveling kit to align a specialized target board, and then using the software to tell the car's computer to relearn the sensor's position. This is a perfect example of how the line between a mechanic and a computer programmer has blurred into non-existence. The worth of the class is found in these specific, high-tech procedures that simply cannot be learned by watching a 2015-era repair video. We also have to consider the legal liability of the 2026 technician. If you perform a software update or a calibration and the car is later involved in an accident, the vehicle's event data recorder, or the black box, will show exactly what software version was running and who performed the last calibration. Formal education provides the documentation and the standardized procedural training to ensure that your work meets federal motor vehicle safety standards. Case studies from legal firms specializing in automotive liability show that unauthorized software modification is becoming a primary reason for insurance companies to deny claims after a collision. By taking a certified class, you are learning the industry standard chain of custody for vehicle data. Furthermore, the 2026 curriculum covers the fascinating area of feature-on-demand ethics. As cars move toward a model where you pay for horsepower or battery range via a subscription, the temptation to chip or tune the car to unlock these features is at an all-time high. A professional auto repair class explores the potential outcomes of these actions, from the voiding of the powertrain warranty to the potential for the car to fail a state emissions or safety inspection. In some states, the 2026 inspection protocols now include a checksum of the engine control unit software. If the numbers don't match the factory records, the car is immediately grounded. This is the hidden knowledge that makes a 2026 class worth every penny for anyone looking to stay on the right side of the law while maintaining their vehicle. But even if you understand the software, there is a looming physical reality that many are ignoring. While we talk about code and clouds, the actual hardware of 2026 vehicles has become more fragile and more expensive. A single headlight assembly on a modern truck can now cost $3,000 due to the integrated cooling fans and micro-LED controllers inside. If you break a plastic clip while trying to access a digital module, you might have just wiped out an entire month's worth of savings. This leads us to the next critical pillar of our masterclass, the brutal economics of the 2026 toolbox. As we move forward, we have to ask, even if you have the knowledge and the digital access, can you actually afford the physical tools required to touch a 2026 vehicle? The gap between a consumer-grade wrench and a professional-grade sensor calibration rig is widening into a canyon. In the next part, we are going to break down the tool inflation crisis and show you exactly which 5 tools are now mandatory for every 2026 garage, and which ones are a total waste of your money. We will look at why your old torque wrench might actually be damaging your new car's composite materials. The concept of the $200 mechanic starter set from a big box retailer is a relic of the past that died somewhere around 2022. In 2026, we are dealing with what industry analysts call tool inflation, a phenomenon where the cost of the entry-level equipment required to safely touch a vehicle has outpaced the cost of the vehicle's initial down payment. If you are sitting in a garage in a city like Denver or Charlotte, looking at a toolbox filled with hand-me-down wrenches from your father, you are holding a collection of historical artifacts, not a repair kit. To understand why an auto repair class is worth it in 2026, You have to understand the specific engineering shift toward composite materials and torque-to-yield fasteners that have made these old tools not just obsolete, but actively dangerous to the health of a modern car. Consider the case study of Dave, a dedicated DIY enthusiast in Denver, who recently purchased a 2025 model year pickup truck. Dave is the kind of guy who has changed his own oil for 20 years. When he decided to install a leveling kit on his new truck, he reached for his trusty 1998-era click-type torque wrench to tighten the suspension components. In his mind, 80 foot-pounds was 80 foot-pounds regardless of the year. However, his new truck utilizes ultra-high-strength steel, UHSS, fasteners paired with aluminum alloy knuckles to reduce unsprung weight. Many of these bolts are designed as torque-to-yield, or TTY fasteners. This means they are engineered to stretch slightly during the final tightening phase to provide a more consistent clamping force. Dave set his old wrench to the specification, but because the internal spring of his 20-year-old tool had lost its calibration by just 8%, and because he didn't realize the specification required an additional 90-degree turn after the initial torque, he overstressed the aluminum threads. As he applied the final turn, the bolt didn't click. Instead, the threads inside the expensive steering knuckle sheared off entirely. What should have been a simple Saturday project turned into a $2,400 nightmare involving a flatbed tow to a specialized machine shop and the replacement of a proprietary steering assembly that was on backorder for 6 weeks. In a 2026 auto repair class, the first thing you learn is that the digital torque wrench is no longer a luxury. It is a mandatory diagnostic instrument. These modern tools don't just measure force. They measure the angle of rotation and the rate of tension. A 2026 curriculum provides you with a step-by-step procedure for using these tools. You learn how to clean the threads, because even a drop of oil on a dry-spec bolt can increase the actual clamping force by 30% and cause a fracture. And you learn how to program the tool for the specific multi-stage tightening sequences required by 2026 manufacturers. The class justifies its cost by preventing a single sheared bolt in a magnesium engine block, which in the current economy, can easily cost more than a full semester of tuition. Beyond the wrenches, we have to look at the 5 mandatory tools for the 2026 garage. If you are taking a class, you are essentially paying for a laboratory environment where you can master these without the 5-figure upfront investment. First is the bidirectional diagnostic scanner with CAN FD and DUIP support. In 2026, the standard controller area network CAN has been replaced by flexible data rate, CAN FD, and diagnostics over IP, Internet Protocol. Older scanners simply cannot talk to the car. They see a wall of encrypted data. A professional class teaches you how to use these scanners to perform an electronic parking brake, EPB, service retraction. Imagine a scenario where you try to change your rear brake pads on a 2026 sedan using a traditional C-clamp to push the piston back. Without the scanner to put the internal electric motor into service mode, you will snap the plastic gears inside the $800 caliper instantly. The class shows you how to command the vehicle's computer to retract the pads electronically, a process that takes 10 seconds but requires a $1,500 tool you likely don't own. The second mandatory tool is a high-impedance digital multimeter with the Cat3 1000V rating. This is the safety barrier between you and the high-voltage systems of a hybrid or electric vehicle. In a 2026 masterclass, you are taught that you never trust a dashboard light to tell you the power is off. You learn the live-dead-live test. You check a known live circuit, you check the car's high-voltage bus, and then you check the live circuit again to ensure your meter is functioning. This protocol is the difference between a successful repair and a life-altering accident. Third is the thermal imaging camera. In the complex electrical grid of a 2026 vehicle, finding a parasitic drain, something that kills your battery overnight, is like finding a needle in a haystack. There are over 50 control modules that are supposed to go to sleep when the car is off. A student in a 2026 class is taught to scan the fuse box with a thermal camera 30 minutes after the car is shut down. A module that is still drawing power will show up as a bright orange heat signature on the screen. This allows you to identify a faulty relay or a hung-up software process in seconds, rather than spend 8 hours pulling fuses one by one. Fourth is the digital oscilloscope. As sensors become more precise, the simple on or off readings of a multimeter are no longer enough. You need to see the heartbeat of the engine's sensors. A class teaches you how to backprobe a camshaft position sensor to see the actual square wave signal. If the wave is rounded or has noise on the line, you know you have a wiring harness issue rather than a mechanical failure. This prevents the common mistake of replacing expensive sensors when the real problem is a $2 connector. Fifth is the Specialized Battery Management System, BMS maintainer. In 2026, you cannot simply jumpstart a car and drive off. The car's computer tracks the age and health of the battery to adjust the alternator's output. If you replace a battery without registering it via a BMS tool, the car will continue to charge the new battery as if it were an old, failing one, effectively cutting its lifespan in half within 6 months. The historical trends of the last 5 years show that the 300-piece mechanical tool sets that used to fill garage walls are becoming a waste of money. In 2026, you need 30 specific mechanical tools and 5 very expensive digital ones. By taking an auto repair class, you are essentially leasing time on these digital tools, while learning the specialized physics of modern fasteners. You are learning why a 2026 chassis uses structural adhesives and rivets instead of welds, and why using a traditional pry bar on a carbon fiber reinforced plastic, CFRP, frame rail can cause an invisible structural failure that compromises the car's safety in a future collision. But even with the best tools and the best knowledge of software, there is a looming crisis that most 2026 car owners are completely unprepared for. It is the hidden chemistry of the modern engine and the battery management paradox. We are seeing a massive spike in catastrophic failures caused by something as simple as the wrong type of coolant or a misunderstood battery chemistry. In the next part, we are going to dive into the liquid engineering of 2026 and why the wrong fluid in your car's thermal management system is now a $5,000 mistake that your insurance will never cover. We will look at the case of the crystallizing coolant that is bricking electric motors across the United States. The phenomenon of crystallizing coolant is not a myth or a rare manufacturing defect. In 2026, it is a daily reality in repair bays across the United States. To understand why an auto repair class is worth your time, you must understand that the liquid running through your car is no longer just a mixture of water and antifreeze. It is now a highly specialized chemical compound designed to manage the extreme thermal loads of high-density battery packs and silicon carbide inverters. Historically, if you saw a low coolant light, you could stop at any convenience store, grab a gallon of universal green or orange fluid, and top it off. In 2026, doing that is the equivalent of pouring sugar into a gas tank. Imagine a character named Elena in Seattle. Elena is a tech-savvy professional who owns a 2025 long-range electric SUV. One morning, she receives a notification on her phone that her battery thermal management system is low on fluid. Being proactive and wanting to save $100 on a dealership visit, she goes to a local big box retailer and buys a jug labeled for all makes and models. She tops off the reservoir and goes about her week. What Elena doesn't realize is that her specific vehicle requires a specialized low conductivity or dielectric coolant. This fluid is designed to be non-conductive so that if a cooling plate inside the battery pack develops a microscopic leak, the fluid won't cause a short circuit between the high-voltage cells. The universal coolant Elena bought is highly conductive. Within 48 hours of driving, the chemistry of the two fluids begins to react. The silicates in the cheap coolant begin to drop out of suspension, forming a gritty, abrasive sludge. This is the crystallization process. This sludge starts by clogging the microscopic fins of the battery cooling jacket. Then it moves to the high-voltage heater, a component that uses electricity to warm the battery in Seattle's chilly mornings. The heater, now unable to circulate fluid, overheats and burns out its internal circuitry. Elena's car suddenly throws a critical system failure code and shuts down in the middle of a busy intersection. In a 2026 auto repair class, you are taught the step-by-step chemistry of these fluids. You learn how to use a refractometer, a precision optical instrument that measures how light bends through a liquid to determine its exact concentration and health. A class doesn't just tell you to use the right fluid. It shows you the potential outcomes of mixing OAT, organic acid technology, with HOAT, hybrid organic acid technology. You see firsthand under a microscope how mixing these chemicals can create a gelatinous mass that bricks a $5,000 thermal management module. For Elena, the case study ends in a financial disaster. When she tows her car to the shop, the technician takes a fluid sample. Because the chemistry has been altered by an unapproved fluid, the manufacturer denies the warranty claim. Even worse, her insurance provider classifies the event as mechanical breakdown due to improper maintenance, which is an excluded peril in almost every 2026 policy. Elena is left with a $7,000 bill for a new cooling loop, a heater, and the labor to drop the entire 3,000-pound battery pack to flush the system. This brings us to the battery management paradox, a core pillar of any 2026 automotive masterclass. As a vehicle owner or technician, you are constantly balancing two opposing forces: the desire for ultra-fast charging and the biological-like aging of the lithium-ion cells. In 2026, the United States market is flooded with third-party software tools that claim to unlock faster charging speeds for older EVs. A formal auto repair class teaches you why this is a high-stakes gamble. You learn about the state of health (SOH) versus the state of charge (SOC). You learn that every time you use a level 3 fast charger, the internal resistance of the battery creates an immense amount of heat. If the cooling system is even 10% less efficient due to old or incorrect fluid, that heat causes the formation of lithium dendrites, microscopic spikes that grow inside the battery. Eventually, these spikes can pierce the separator, leading to a thermal runaway event. A 2026 class provides the data-driven framework to understand these risks. You learn to interpret the cell balancing data on a diagnostic screen. If you see one group of cells at 3.82 volts and another at 3.75 volts, you are looking at the early warning signs of a failing pack. Without this class, you might assume the battery is fine because the dashboard says 95% charge. With the class, you know that the car's computer is actually working overtime to hide those imbalances from the user to prevent range anxiety. This knowledge allows you to make informed decisions about whether to keep a vehicle or trade it in before a catastrophic failure occurs. Furthermore, we must address the complexity of modern multi-loop systems. A 2026 high-performance hybrid doesn't just have one radiator. It often has 3 or 4 separate cooling circuits. Loop 1 handles the internal combustion engine at 210 degrees Fahrenheit. Loop 2 handles the electric motors and inverters at 140 degrees. Loop 3 is a dedicated refrigerated circuit for the battery pack that can actually drop below ambient temperature. Loop 4 handles the passenger cabin's heat pump. These loops are interconnected through a series of proportional valves, essentially traffic cops for heat. If you are taking a 2026 auto repair class, you spend hours studying the flowcharts of these valves. You learn how to use a scan tool to command these valves to open for a process called vacuum filling. In 2026, you cannot simply pour coolant into a funnel and burp the air out by running the engine. If air is trapped in the battery loop, that section of the battery will overheat and degrade. You must use a vacuum filling tool that sucks all the air out of the system, creating a near-perfect vacuum, before allowing the atmospheric pressure to push the new, precisely measured fluid into every corner of the cooling jackets. The historical trends of the last decade show that fluid maintenance has moved from being a low-skill task to a high-precision laboratory procedure. Case studies from technical institutes in Texas and Florida show that the number one cause of comebacks, cars that return to the shop because the first fix didn't work, is air trapped in these complex cooling loops. A technician who hasn't taken a 2026 level class is a liability to their shop and their customers. But what if you aren't looking to be a professional? Is the depth of this knowledge still worth it for a regular driver in the US? Consider the rise of the used EV and hybrid market. In 2026, there is a massive secondary market for vehicles that are 5 to 8 years old. Many of these cars are reaching the point where their specialized fluids need their first major service. If you are buying a used car, how do you know if the previous owner was like Elena? How do you know if the battery cooling loop is filled with liquid gold or crystallized sludge? The answer lies in a specific set of tests that only a trained eye can perform. In the next part of this masterclass, we are going to expose the clean car scam of 2026. We will show you the 3 specific data points you must pull from a vehicle's computer before you ever sign a title, and why a shiny exterior often hides a battery pack that is on the verge of a 50% capacity drop. We will look at how range-fudging software is being used by unscrupulous sellers, and how your auto repair class knowledge is the only thing that can detect it. The clean car scam of 2026 is a sophisticated evolution of the odometer fraud that plagued the used car market for decades. Historically, a dishonest seller would mechanically roll back the numbers on a dashboard to make a vehicle appear less used. In the era of the software-defined vehicle, that practice has been replaced by battery management system manipulation, often referred to in technical circles as a ghost reset. Imagine a character named Tyler in Phoenix, Arizona. Tyler is looking for a used electric commuter car in the spring of 2026. He finds a 2021 model with 50,000 miles on it. The exterior is flawless, the interior smells new, and when he turns it on, the dashboard proudly displays a battery state of health of 98%. Tyler thinks he is getting a vehicle with years of life left, especially since Phoenix's extreme heat is notorious for degrading lithium-ion cells. He buys the car from a private seller on a digital marketplace. 2 weeks later, as the Arizona summer begins to peak at 110 degrees, Tyler notices something alarming. While the dashboard claims he has 200 miles of range at a full charge, he barely makes it 80 miles before the car enters turtle mode. Tyler has fallen victim to the 2026 range fudging epidemic. The seller used a gray market diagnostic tool, the kind we discussed in Part 3, to perform a hard reset of the battery management system's learned values. This forced the car's computer to forget 5 years of heat-induced degradation and revert to its factory default health estimates. The car wasn't actually healthy. It was just digitally lobotomized. An auto repair class in 2026 is worth its weight in gold specifically because it teaches you how to look past these digital lies. In a masterclass environment, Tyler would have learned the step-by-step process of performing a stress-induced voltage drop test. This is a procedure that no standard consumer knows how to execute. You don't just look at the percentage on the screen. Instead, you connect a high-speed data logger to the vehicle's diagnostic port and take the car for a short, high-load drive, typically a steep hill or a series of rapid accelerations. A trained student knows to monitor the voltage spread between the individual cells in the pack during this high-amperage draw. In a healthy pack, the cells should stay within 20 millivolts of each other. In Tyler's car, under load, several cells would have plummeted in voltage compared to their neighbors, indicating high internal resistance and physical degradation that no software reset can hide. Step by step, a 2026 automotive curriculum teaches you to verify the cumulative energy throughput. Every modern vehicle tracks exactly how many kilowatt hours have passed through the battery over its lifetime. While a seller can reset the health percentage, it is significantly harder to wipe the deep-level EEPROM data that records total energy flow. By taking a class, you learn how to calculate the ratio between the odometer reading and the energy throughput. If the energy throughput is suspiciously high for the mileage, it indicates the car was likely used for heavy towing or frequent high-speed DC fast charging, both of which are historical trends for premature battery failure. This data-driven skepticism is a superpower in the 2026 used market. Consider another case study involving the charging port itself. In 2026, many vehicles have moved to the North American Charging Standard, or NACS, but many older used vehicles still use the CCS combo. A student in an auto repair class learns that these ports are not just pieces of plastic and copper, they are high thermal stress components. Imagine if Tyler had looked into the charging port with a thermal camera, a tool provided in his vocational lab. He would have seen abnormal heat patterns around the DC pins, suggesting that the previous owner had used a worn-out home charger that caused microarcing. This damage is invisible to the naked eye but can lead to a $2,000 port replacement 6 months down the road. The historical trends of 2026 show that the gap between the perceived value of a car and its actual technical state has never been wider. We are seeing a 35% increase in litigation involving misrepresented battery health in the United States. An auto repair class provides you with the technical literacy to demand a battery health certificate that includes a full discharge cycle log. You learn to ask the seller for the DC to AC charging ratio. If a car has been fast charged 90% of its life, the potential outcomes for that battery are far worse than a car that was slow charged overnight in a climate-controlled garage. The class teaches you that in 2026, the garage is the new fountain of youth for vehicles. Beyond the battery, the 2026 auto repair class dives into the world of over-the-air OTA update history. Think of this as the digital equivalent of a Carfax report. Every time a manufacturer pushes a software patch to a car, it leaves a digital footprint. Some of these patches are for entertainment, but others are critical safety recalls for the automated steering or the thermal management valves we discussed in Part 5. A student is taught how to access the update log to see if the car is running on a stale version of the OS. If a seller has intentionally disconnected the car from the internet to avoid an update that might throttle performance to protect a failing component, a trained technician will spot that gap immediately. Imagine if you were looking at a 2024 luxury SUV that seems like a bargain. Without a class, you might miss the fact that the car is 3 versions behind on its ADAS software. Why? Because the front-facing camera module is failing, and the car cannot complete the update until the hardware is replaced. That bargain SUV just became an $8,000 liability. The auto repair class turns you into a digital detective who can see these red flags before money changes hands. The depth of this knowledge also extends to the physical structure of 2026 vehicles, which increasingly use structural adhesives instead of traditional welds. In a lab setting, you learn how to use an ultrasonic thickness gauge to check the integrity of the frame rails. If a car was in a major accident and repaired by a shop that didn't follow the precise curing times for the structural epoxy, the car might look perfect but lack the structural rigidity to protect you in a second crash. Historical trends in the 2025 insurance market show a spike in total loss declarations for minor accidents precisely because the underlying structural bonds were compromised by poor quality previous repairs. As we conclude this deep dive into the 2026 used vehicle market, you should realize that your knowledge is the only barrier between you and a catastrophic financial decision. The clean car scam relies on your technical ignorance. It relies on the hope that you will trust the dashboard and the shiny paint. But once you have mastered the data logging, the thermal analysis, and the chemical refractometry taught in a modern auto repair class, you are no longer a victim, you are an authority. However, even if you buy the perfect car, there is one more hurdle that is catching the entire United States public off guard. It's the infrastructure in your own home. In 2026, the way you charge your car is just as important as how you drive it. In the next part, we are going to look at the charging infrastructure trap. We will explore why 40% of residential electrical panels in the US are technically illegal for high-speed EV charging, and how a simple mistake in your garage wiring can lead to a fire that your homeowner's insurance might not cover. We will look at the case of the meltdown in Miami and what it means for your home's resale value. The technical bridge between a vehicle and a home has become the most dangerous blind spot for American homeowners in 2026. Historically, a car was an isolated machine that lived in a garage, only interacting with the house through the occasional drip of oil on the concrete. But today, the car is an integrated component of the residential electrical grid. If you are taking an auto repair class in 2026, you are not just learning about suspension and software, you are learning about the high amperage physics of your own home. The charging infrastructure trap is a term coined by forensic electricians to describe the thousands of residential fires caused by the mismatch between legacy home wiring and the relentless demands of modern electric vehicle service equipment, or EVSE. Consider the case study of Ricardo in Miami. Ricardo is a representative character for many in the United States who upgraded to a high-performance electric SUV in early 2026. This vehicle featured a massive 120 kilowatt-hour battery pack and came with the recommendation for a 60-amp level 2 home charging station to allow for rapid overnight replenishment. Ricardo, wanting to save on installation costs, hired a general handyman to install a standard NEMA 14-50 outlet in his garage. On the surface, everything looked correct. The car charged, the lights stayed on, and the dashboard showed a full range every morning. However, under the skin of the garage wall, a catastrophe was brewing. In a 2026 auto repair class, one of the most critical modules covers the concept of continuous load. Most household appliances like a toaster or a vacuum cleaner run for a few minutes at a time. An electric vehicle charger is a continuous load, meaning it draws its maximum rated amperage for 8, 10, or even 12 hours straight. Historical trends in the National Electrical Code, specifically Article 625, require that a circuit for an EV charger be rated for 125% of the load it will carry. Ricardo's 60-amp charger was drawing 48 amps continuously through a circuit that was technically rated for 50, but using components that were never designed for the thermal stress of a decade-long charge cycle. The meltdown in Miami occurred during a particularly humid July night. Because the handyman had used a budget-grade outlet designed for a clothes dryer, which only runs for 45 minutes at a time, the internal copper contacts began to oxidize under the extreme heat. In an auto repair class, you learn about the physics of resistance. As a connection degrades, its resistance increases, which generates more heat, which further degrades the connection. This is a positive feedback loop of thermal failure. By 3 a.m., the temperature inside Ricardo's wall had reached over 600 degrees Fahrenheit. The plastic insulation on the Romex wiring liquefied, and a sustained electrical arc ignited the wooden studs of the garage. The potential outcomes for Ricardo were devastating. Not only did he lose his new vehicle and half of his home to the fire, but his homeowner's insurance company denied the claim after a fire marshal's investigation. The investigation found that the installation had been performed without a permit and use non-industrial grade components that did not meet the 2026 safety standards for continuous load EVSE. This is where the ROI of an auto repair class becomes undeniable. A student in a 2026 curriculum is taught how to perform a load calculation on a residential electrical panel. You learn to use a torque screwdriver, a tool most people don't even know exists, to ensure that every lug in the breaker box is tightened to the exact inch-pound specification required by the manufacturer. Step by step, the 2026 Masterclass teaches you how to identify the service entrance capacity. You learn that many older United States homes have a 100 amp service. If you try to pull 48 amps for a car while the air conditioner, the water heater, and the electric range are running, you are operating at the absolute edge of the system's safety margin. A student learns to install and configure smart load management systems. These are digital controllers that communicate between the car and the house, automatically throttling the car's charging speed if the house's total demand gets too high. Without this knowledge, you are playing a game of electrical Russian roulette every time you plug in your vehicle. Beyond safety, there is the massive financial shift toward V2H, or vehicle-to-home technology. In 2026, your car is no longer just a depreciating asset. It is a backup generator. Imagine if a hurricane or a winter storm knocks out the power grid. A modern EV can power an average American home for 3 to 5 days. But to do this, you need a bidirectional inverter and a specialized transfer switch. An auto repair class in 2026 covers the mechatronics of these systems. You learn how the car's DC to DC converter interacts with the home's AC panel. You learn the safety protocols to ensure that your car doesn't backfeed electricity into the utility lines, which could potentially be lethal for linemen working to repair the grid. Case studies from the 2025 California wildfires show that homeowners who had the technical literacy to manage their own V2H systems were able to maintain refrigeration and medical equipment for days, while their neighbors were left in total darkness. The worth of the class in this context is measured in resilience and security. Furthermore, we must look at the EV Ready certification for home resale. In 2026, savvy homebuyers are asking for certified electrical audits of the garage. A home with a documented, permitted, and thermally tested charging setup is currently commanding a 3 to 5% premium in the real estate market. If you can perform that audit yourself or oversee a contractor with the authority of a trained technician, you are protecting your home's future value. The data regarding panel upgrades is also startling. In 2026, the average cost for a licensed electrician to upgrade a home service from 100 to 200 amps is between $4,000 and $6,000. A student in an auto repair class learns that an upgrade isn't always necessary. By mastering the settings of the vehicle's onboard charger and understanding the time of use rates offered by utility companies, you can often configure a safe, efficient charging schedule that fits within your existing electrical envelope. This single piece of knowledge can save you thousands of dollars in unnecessary infrastructure costs. However, the charging infrastructure trap has a second, more subtle layer: the public grid paradox. As you travel across the United States in 2026, you are relying on a fragmented network of public fast chargers that are frequently out of order or worse, derated to half their advertised speed. If you don't understand the thermal limits of your vehicle's battery intake, you might spend 2 hours at a hyper-fast charger, only to realize your car was limiting the speed to protect itself from a faulty cooling loop, the very same loop we discussed in Part 5. The 2026 Auto Repair class gives you the diagnostic authority to know exactly why your car is charging slowly. Is it the charger? Is it the cable? Or is it an internal sensor in your car that is falsely reporting an overheat condition? In a world where every minute at a public charger costs money, this technical clarity is the difference between a seamless road trip and a logistical nightmare. As we look toward the final stages of this masterclass, we have to address the most controversial part of the 2026 automotive world. It's not about the car, the software, or the house. It's about the autonomous responsibility. As vehicles take over more of the driving tasks, who is responsible for the maintenance of the LiDAR and camera systems that are literally keeping you alive? In the next part, we are going to dive into the calibration crisis. We will look at why a dirty sensor or a misaligned bumper is now a legal liability that could land you in court, and why your auto repair class might be the only thing standing between you and a system failure lawsuit. We will examine the case of the invisible pedestrian and what it taught the industry about the life and death importance of sensor hygiene. The case of the invisible pedestrian began in a rainy Chicago intersection in November 2025. Chloe, a 34-year-old architect, was driving her 2024 luxury sedan, a vehicle marketed for its peerless safety suite. 6 months prior, she had backed into a parking bollard at a low speed. To the naked eye, the bumper looked fine, perhaps a few scratches on the plastic, but nothing that warranted a trip to a body shop. What Chloe didn't realize was that the impact had compressed the plastic bracket holding the short-range rear and side-facing radar. It was tilted downward by exactly 1.8 degrees. In the world of 2026 automotive engineering, 1.8 degrees is an eternity. Think about the geometry. If a sensor is misaligned by less than 2 degrees, the error is negligible at 3 feet. But as that radar beam extends out to 100 feet, that small angular error translates into a massive blind spot. In Chloe's case, the car's software was receiving data that the road was clear, but the sensor was actually looking at 0.5 feet below the horizon. When a cyclist entered her lane from the side, the car's system, which was supposed to trigger an emergency swerve and brake maneuver, did nothing. The car's black box, the event data recorder, later showed that the system had a high confidence level that the path was clear. Chloe was held legally responsible for the resulting collision because she had failed to perform a mandated calibration after a physical impact. In a 2026 auto repair class, you are taught the step-by-step protocol for advanced driver assistance systems, or ADAS, health checks. You learn that in the United States, several major insurance carriers have begun to include clauses in their policies that require a certified sensor calibration every time a vehicle is involved in an impact over 5 miles per hour, or even after a simple windshield replacement. Why the windshield? Because the front-facing camera is mounted directly to the glass. If the new glass has a different refractive index or if the camera is off by a millimeter, the car might miscalculate the distance to the vehicle ahead by several meters. A student in a 2026 lab spends days mastering the 2 types of calibration. Static calibration is a clinical procedure. You place the vehicle in a bay with a perfectly level floor. You use laser-guided measuring tools to place target boards, large panels with specific high-contrast patterns, around the vehicle. You then connect your diagnostic laptop and initiate a handshake with the car's central gateway. The car's cameras look at the boards and adjust their internal software logic to ensure they know exactly where center is. This process is highly sensitive to light. A single shadow across a target board can cause a calibration failure. Dynamic calibration is the opposite. It requires you to drive the vehicle under very specific conditions. You might have to maintain a speed of exactly 45 miles per hour on a road with clear lane markings for 15 consecutive minutes. If you hit a stoplight or if the sun is too low in the sky, the car will abort the process and you have to start over. An auto repair class provides you with the specific drive cycle maps for your region, showing you which stretches of highway are suitable for these digital relearn procedures. Now let's talk about the mundane reality of sensor hygiene. In 2026, we are seeing a historical trend of system failures caused by improper vehicle detailing. Imagine if you apply a high-end ceramic coating or a heavy-duty wax to your car's bumper. While it makes the car look beautiful, some of these coatings contain metallic particles or thick polymers that can attenuate the radar signal. In a classroom setting, you learn to use a specialized signal strength meter to test through the plastic bumper covers. You learn that a single layer of aftermarket paint that is too thick can blind a radar sensor, even if it looks perfect to a human eye. Consider the case of a technician in Texas who was sued because he used an unapproved plastic filler to repair a small crack in a bumper. The filler contained carbon fibers which scattered the radar waves, causing the car to see ghosts. The car began slamming on the brakes at highway speeds because it thought there was an obstacle in front of it that didn't exist. This technician hadn't taken a 2026 level mechatronics course and didn't understand that a bumper is no longer just a piece of plastic. It is a complex optical lens for the car's electronic brain. Data from the 2025 National Highway Traffic Safety Administration reports show that nearly 12% of late-model vehicle accidents involve some form of ADAS degradation. This is the new frontier of automotive repair. In your class, you learn to read the confidence scores within the vehicle's diagnostic data. Every time a sensor makes a decision, it assigns itself a score. If a sensor's confidence is consistently low, the class teaches you how to trace the fault. Is it a dirty lens, a failing heater element designed to melt snow off the sensor, or a wiring harness issue? As we enter the mid-2020s, LiDAR, or light detection and ranging, has moved from experimental vehicles to mainstream consumer SUVs. These sensors use laser pulses to create a 3D map of the environment. They are incredibly powerful but also incredibly fragile. A A student in a 2026 masterclass learns the total cost of care for LiDAR. These units are often liquid-cooled and integrated into the car's primary thermal loop. If the coolant becomes contaminated, the same issue we discussed in Part 5, the LiDAR unit can overheat and its laser diode will degrade. A new LiDAR assembly can cost upwards of $4,000. The class teaches you how to perform a cleaning cycle using specialized pressurized air and solvent systems that are built into the car, but often require a manual software trigger to operate during maintenance. Furthermore, a student must understand the difference between 77 GHz and 24 GHz radar systems. The higher frequency sensors provide better resolution, but are more susceptible to interference from heavy rain or snow. In an auto repair class, you learn how to diagnose the sensor's heater circuits. If the heater fails, the sensor becomes occluded by ice, and the car's adaptive cruise control will drop out in the middle of a winter storm. You learn to test these circuits using a pulse width modulation signal on your oscilloscope to ensure the heating element isn't just getting power, but is getting the correct duty cycle to maintain the sensor's operating temperature. Ultimately, an auto repair class in 2026 is worth it because it transitions you from being a passenger in your own life to being the commander of your technology. You aren't just fixing things, you are performing precision digital alignment. You are the only person who can verify that the car's software and the car's hardware are speaking the same language. Without this knowledge, you are driving a 4,000-pound robot that might be hallucinating. But there is one final, hidden threat to the 2026 vehicle owner that no amount of sensor cleaning can fix. It is the end of support crisis. As cars become more like smartphones, manufacturers are beginning to treat them like smartphones, with expiration dates. In the next part, we are going to look at the digital sunset. We will explore what happens when the manufacturer decides your 2024 model is no longer worth the cloud server costs to keep it running. We will look at the rise of zombie vehicles on American roads, and how your auto repair class is the only way to keep your car from being remotely deactivated by a corporate headquarters. The digital sunset is not just a theoretical risk, it is a documented historical trend that reached a boiling point in early 2026. To understand why an auto repair class is worth it today, you must understand the concept of planned digital obsolescence. Historically, if you owned a 1990 pickup truck, it would run as long as you provided spark, fuel, and air. In 2026, your vehicle requires a fourth, invisible ingredient: a valid security certificate from a remote server. When a manufacturer decides that a specific model year is no longer profitable to support, or if a startup EV company goes bankrupt, those servers go dark. This creates what the industry now calls zombie vehicles, perfectly functional machines that are effectively lobotomized because they can no longer perform the digital handshake required to authorize a battery charge or a firmware boot up. Imagine a character named Ava in Austin, Texas. Ava owns a 2021 high-performance electric sedan from a boutique manufacturer that went into receivership in late 2025. One Tuesday morning, Ava tries to start her car, but the center console displays a critical error: authentication server not found. Because the manufacturer's cloud infrastructure has been liquidated, Ava's car cannot verify its own software integrity. It has entered a permanent lockout state. To the local dealership, which is now a vacant lot, this car is scrap metal. To a traditional mechanic, it is a mystery. But to a student in a 2026 auto repair masterclass, Ava's car is a salvageable asset. In a modern 2026 curriculum, the module on post-warranty sovereignty is where the real value of the class is revealed. You are taught the step-by-step process of hardware emulation. This is not about illegal hacking. It is about the educational study of the Telematics Control Unit, or TCU. You learn how to identify the specific EEPROM chips that store the car's identity. A 2026 class provides you with the laboratory equipment to read these chips, and using open-source community-maintained firmware, teach the car to look for a local server, perhaps a small device plugged into your home network, instead of a non-existent corporate cloud. This is the difference between a $30,000 loss and a $50 hardware fix. Historical trends show that the first wave of this crisis hit in 2022 with the sunsetting of 3G networks, which disabled remote features for millions of vehicles. By 2026, the stakes are much higher because the 4G modems in early 2020s cars are being phased out in favor of the unified 6G-ready infrastructure being rolled out across the United States. If you don't know how to perform a TCU swap, your car loses its ability to receive safety-critical navigation updates or manage its own battery preconditioning. An auto repair class teaches you the specific pinout diagrams for these modems. You learn how to solder high-frequency antennas and how to reconfigure the vehicle's Linux-based operating system to recognize new cellular hardware. This is high-level mechatronics that simply cannot be found in a hobbyist forum. It requires the structured, deep-dive environment of a certified vocational program. Consider the case study of a small delivery fleet in Portland. In early 2026, they faced a fleet-wide digital sunset when their software provider transitioned to a new encrypted API that was incompatible with their 3-year-old vans. The potential outcomes were bankruptcy for the business or a multi-million-dollar fleet replacement. However, the head of maintenance was a recent graduate of a 2026 Automotive Mechatronics program. Using the skills learned in the legacy logic unit of his course, he was able to develop a bridge module, a small piece of hardware that translated the old vehicle's language into the new API's requirements. This case study is now used in classrooms to demonstrate how technical literacy is the ultimate form of business insurance in the mid-2020s. Furthermore, we must address the component protection lock. In 2026, if you buy a used headlight or a window motor from a salvage yard and plug it into your car, it likely won't work. The car's central computer will recognize that the serial number of the new part doesn't match the original factory manifest. It will flag the part as stolen or unauthorized and disable the circuit. In an auto repair class, you learn the step-by-step procedure for VIN matching used components. You learn how to use specialized J2534 pass-through tools to log into the secure data release model. You learn the legal and technical pathways to prove to the car's computer that you are performing a legitimate repair with a recycled part. This knowledge allows you to bypass the manufacturer's new parts-only monopoly, which can save you upwards of 70% on major repairs. The 2026 curriculum also dives deep into the digital forensic side of maintenance. As cars become more autonomous, they record an incredible amount of metadata. If your car's performance is degrading, it might not be a mechanical part. It might be a log file bloat, or a corrupted database within the infotainment system that is hogging the processor cycles needed for the engine management. A 2026 student learns how to perform a digital tune-up. This involves clearing cache files, verifying checksums on critical system partitions, and ensuring that the car's internal solid-state drive isn't reaching its write limit. Historical trends in 2025 showed that 15% of random stalling issues in modern crossovers were actually caused by failing internal storage chips, not mechanical fuel pumps. Imagine the high-stakes scenario of a zombie car during a regional evacuation. If the cellular towers are down and the car can't call home to verify its subscription-based features, will the car still drive? In a 2026 class, you learn how to configure offline mode for your vehicle's critical systems. You learn which modules are fail-safe and which are fail-secure. This level of understanding provides a sense of security that no guaranteed marketing brochure can match. You aren't relying on a corporation's benevolence. You are relying on your own technical competence. We are also seeing the rise of community firmware in the United States. Just as people use open-source operating systems for their computers, a movement of 2026 automotive enthusiasts is creating long-term support, LTS versions of vehicle software. An auto repair class is your gateway into this world. You learn the ethics of open-source repair, the legal protections provided by the latest 2026 right to repair amendments, and how to verify that a community-created patch is safe for your specific vehicle architecture. You learn to use a sandbox environment, a separate computer that mimics your car's brain, to test a software update before you ever apply it to the actual vehicle. This prevents the brick driveway syndrome that has claimed so many DIY projects in the last 3 years. By the time you reach the end of a 2026 masterclass, your perspective on worth has shifted. You no longer see a car as a black box that you pray stays working. You see it as a modular system of hardware and software that you have the authority to maintain, upgrade, and protect. The class isn't just about saving money on an oil change. It's about preventing your $40,000 asset from becoming an oversized paperweight because of a corporate boardroom decision 500 miles away. But as we reach the conclusion of this 10-part deep dive, we have to face the ultimate question. In a world of AI-driven diagnostics, remote deactivations, and high-voltage hazards, is there still a place for the individual? Or are we moving toward a future where auto repair is a task reserved solely for robots and corporate giants? In the final part of our masterclass, we are going to look at the human dividend of 2026. we will reveal the final shocking data point that proves why the human touch is more valuable now than it was in the age of the carburetor. We will look at the final verdict on the ROI of an auto repair class and give you the 3-step roadmap to choosing the only type of program that is actually worth your time in the current economy. The human dividend in the year 2026 is the final piece of the puzzle that many industry analysts missed during the initial AI gold rush of the early 2020s. To understand why an auto repair class is fundamentally worth it, you have to look at the massive gap between artificial intelligence and human tactile intuition. Imagine a character named Brandon in Chicago. Brandon owns a 2024 electric truck that recently began throwing a series of erratic high-voltage isolation faults. In 2026, most vehicles are equipped with onboard AI diagnostics that can communicate directly with the manufacturer. Brandon's truck sent a data packet to the cloud, and the AI's probabilistic model determined with 88% certainty that the internal DC-to-DC converter had failed. The estimated repair cost sent to Brandon's smartphone was $6,000, including labor. If Brandon had blindly trusted the digital diagnostic, he would have authorized a massive financial outlay for a part that was perfectly functional. However, Brandon had recently completed a 12-week mechatronics masterclass at a local technical college. Instead of looking at the screen, Brandon looked at the context. He used his knowledge of regional historical trends, specifically the impact of Chicago's road salt on underside shielding. He put the vehicle on a lift and used a high-resolution thermal camera, a tool he learned to master in his class, to perform a sweep of the chassis while the vehicle was under a simulated charging load. He didn't see heat at the converter. He saw a tiny, concentrated heat signature at a ground strap that had been partially severed by road debris and then corroded by salt. This is the human dividend. The AI could see the data, but it couldn't see the salt. It couldn't see the physical environment that led to the data anomaly. Brandon spent $15 on a new heavy-duty ground strap in 30 minutes of his time. By applying the diagnostic logic he learned in his class, he realized a return on investment of $5,985 on a single repair. This is not an isolated case study. In 2026, the complexity of vehicle systems has reached a point where AI often defaults to the most expensive modular replacement because it lacks the nuance to identify a subcomponent failure. The potential outcomes for someone with this level of technical literacy in 2026 are categorized into 2 tiers: financial sovereignty and professional leverage. On the financial sovereignty side, the United States public is facing a labor shortage where the wait time for a specialized mechatronics appointment at a dealership can exceed 3 weeks. If you can perform your own sensor calibrations and high-voltage safety checks, you are essentially saving a hidden tax on your mobility. On the professional leverage side, we are seeing a historical trend where starting salaries for technicians who hold an L3 light-duty hybrid/electric vehicle specialist certification are 30% higher than those with traditional ASE certifications. In 2026, the person who can bridge the gap between a laptop and a lug nut is the most valuable person in the shop. This brings us to the final verdict and the 3-step roadmap to choosing the only type of auto repair class worth your time in 2026. The market is currently flooded with legacy programs that are essentially teaching 19th century technology to a 21st century workforce. To ensure you aren't wasting your tuition, you must follow this specific vetting process. Step 1 is the hardware and lab audit. Before you sign a contract, you must walk into the school's lab and look at their diagnostic fleet. If you see a row of cars that are more than 10 years old, walk out. In 2026, a valid program must have at least 2 vehicles with a 400-volt or 800-volt architecture and a functional ADAS calibration bay. Ask to see their oscilloscopes and their J2534 pass-through devices. If the instructor cannot show you a thermal imaging camera or a dedicated EV battery lift, the program is teaching you for the world of 2015, not 2026. You are looking for a facility that resembles a laboratory more than a traditional grease-stained garage. Step 2 is the curriculum software-to-hardware ratio. A program worth its salt in 2026 should dedicate at least 60% of its classroom time to electrical theory, networking, and software architecture. You should be looking for modules with titles like combust topology, cybersecurity and automotive gateways, and battery chemistry and thermal management. If the syllabus is heavily weighted toward rebuilding manual transmissions or grinding brake drums, it is a legacy program. While those skills have niche value, they do not provide the ROI needed to justify the cost of modern education. You need to be learning the language of the software-defined vehicle, which means understanding how to read a hex dump and how to interpret a data packet handshake between a car and a charging station. Step 3 is credential portability and NASTF integration. In the United States, the legal right to repair is tied to your ability to prove you are a qualified professional. A class is only worth it if it provides a direct pathway to becoming a verified member of the National Automotive Service Task Force. This is the organization that manages the digital keys for the vehicle security systems we discussed in Part 3. You need to ask the program director if their curriculum is recognized by major manufacturers for secure gateway access. If the certificate they give you at the end of the semester doesn't allow you to register for a locksmith-level digital ID, you will still be locked out of the most important repairs on 2026 vehicles. The data is clear. An auto repair class in 2026 is an essential investment for anyone looking to maintain their standard of living in a high-tech economy. We have moved past the era where automotive knowledge was a hobby. It is now a fundamental survival skill for the digital age. Whether you are like Brandon, saving thousands by outsmarting an AI diagnostic, or you are looking to enter a workforce that is desperate for your skills, the ROI is found in the depth of your technical authority. You are no longer just a driver. You are a systems administrator for a 4,000-pound mobile computer. However, even as you master the software and the sensors of the consumer vehicle, a new and much larger challenge is looming on the horizon. The technologies we have discussed, LiDAR, high-voltage cooling, and digital sunsets, are currently being scaled up for the massive transition of the United States commercial trucking fleet. The stakes in the world of heavy-duty autonomous freight are 10 times higher, and the systems are 10 times more complex. In the next phase of our deep dive series, we are going to look at the Class 8 crisis. We will explore why the global supply chain is currently resting on the shoulders of a few thousand heavy mechatronics specialists, and why the repair of a single autonomous semi-truck is now a $20,000 event. We will dive into the world of megawatt charging and what it does to a human body if the safety protocols are missed by even a fraction of a second.